distinction that makes them easier compared to the ones where you don't have the equation. So it's kind of like in physics where you got to set up the problem. If you have to set it up, it's more difficult.
Mhm.
So let me share my screen here and try to give you a little bit more clarity. So there's a lot of words here, but they give you this equation. And this graph over here is great. And then there's a question. There's a question here at the end, but they actually could ask many questions. I guess it does ask a couple. They could ask you, and this is a parabola. So some things that you know about a parabola. It has a vertex, and it usually has an x-intercept.
Mhm.
And these are things that they could ask you about when you're doing a problem like this one. But they don't specifically say what is the vertex. And in full disclosure, they can ask for either the x or the y value of the vertex.
Mhm.
But they encode it in a question up here. Same thing with this x-intercept. They are asking you to they'll ask you some question where you have to say, oh, I need the x-intercept. But
Mhm.
if you could forget about all the question, the words and all that, if you're given a parabola, there's really only two things that you ever care about. It's the x-intercepts, which there could be another one, and the vertex. Like those are the most important features of that. So we could do this problem, but I think I just want to I'm going to grab question 3 and kind of illustrate the same sort of idea here. And then we can talk about how you actually find these certain things. Okay. So again, they give you a quadratic in number 3, and you've correctly graphed it here. And this right here is the vertex. It's the in this case, it's the maximum height of the diver.
Mhm.
And there's two parts to the vertex. There's the x and the y value. The y value is the height. The x value is when it happens. So that's maybe another question. The when it occurs, and then the what is it at the top. It's also got this x-intercept. Okay.
Mhm.
So just like the previous problem, there's only so many things they can ask you here. So let's see if we can talk about this very generally and then maybe apply it to a problem or two.
Okay.
So this is the equation of a quadratic. It could also be y equals, but this is the general equation of a quadratic. Okay. If it wants the vertex, and specifically the x value of the vertex, the x value of the vertex is minus b over 2a. Do you remember that from
Mhm.
class? Is that familiar to you?
Yes.
Great. You can also be asked for the vertex y value. Okay. And this is, I got to do this in words, otherwise it's confusing. It's evaluating f of x at the x value of the vertex. Like, let's say this is 2. You put that 2 back in for x in the original function.
Wait, I'm sorry. It cut out. What do you put in for the function?
Whatever the x value of your vertex is. So this first thing that they could ask you for gives you the x value of the vertex always. Down here at number 2, you take whatever this value is and you put it in for x.
Okay.
We're going to do some examples of that, but that's two very important things. And then kind of there's this dashed line here. Number 3 is we can actually set ax squared plus bx plus c equal to 0. and we can solve for x, and these are the x-intercepts. These are where it crosses the x-axis.
Okay.
And some potential ways you might do that would be factoring, quadratic formula, graphing is probably the most common way, I guess, when you're dealing with these problems. But there's only like 3 things that they could ask you for. So let's go back and let's look at a problem here. But I want to make sure there's only these 3 things that they're going to ask you for, but they're going to give it to you in words. It's not going to be just what is the x value of the vertex. It's going to be like, when is the diver at its max position or something.
Mhm.
So we have to consider that as well.
Okay.
So let's look at I don't know, do you want to look at 1 or 3 again for doing this kind of this path here?
Can we do number 3?
Sure. So 3 has the equation y equals, and actually let me write the generic form first. So it's ax squared plus bx plus c, and your problem is minus 4 over 9 x squared plus 24 over 9 x plus 12. So your a is minus 4/9, your b is 24 over 9, and your c is 12.
Mhm.
So one approach to doing these problems, which is very robust, it will always work, is to just find all the things that I just mentioned. It's to say, okay, x is minus b over 2a. This is the x coordinate of the vertex, and you just find it. You just say, okay, well, it's minus 24 over 9 over 2 times minus 4 over 9, and you calculate that.
Okay.
Now, are you comfortable putting this into the calculator?
Yes.
Okay. I'm going to do it as well. If you want to compare your result to mine, I would encourage you to do that.
Okay.
It does work out nicely. I believe it's 3. Yeah, looks like it's 3. Let me know
Yeah,
if you, okay. So
that's what I thought.
if you go back up to what I wrote here, I said evaluating f of x at the x value of the vertex. So we just found x. So we have to take this 3 and put it back in for x. So to find the y value of the vertex, you take this 3 value that we found and you put it in wherever you see an x. See, I took this equation right here and just substituted it in for 3.
And this is to find the y.
The y, yeah. And so the reason we're doing this is because once we know the x and the y and the other intercepts, we can answer the questions. It's going to be one of those 3 numbers. So I get 16 for that.
That's what I got as well.
All right, fantastic. So the third thing we could find is where it crosses the x-axis. So this is 1, this is 2. To do the third thing, you really need to probably graph. Are you allowed to use a graphing calculator on this thing upcoming that you got, or?
Yes.
Okay, so I'm gonna use Desmos graphing because it's a little bit faster than like me trying to do this by hand. And I'll snip in the graph here though for us, so that you've got it to look at. So when I graph it, and this is really critical, because the graph is really nice. Like it tells you, oh, it crosses at 9, that's 9, and it crosses at -3. Okay. And
Mhm.
the problem though is that you have to be able to interpret. You have to be like, well, are those even reasonable? And it depends on the context of the problem. So the physical scenario here is there's a diver. There's a person standing right here, and they're going forward. They're not diving backwards.
Mhm.
So that, like, none of this is reasonable right here. But your calculator doesn't know that. Your calculator has no idea what you're using it for.
Yeah.
So you have to know, oh, this is the only one that I care about. That's number 3.
Okay.
And when I say 3, I'm referring back to, there's only 3 things you can find in a quadratic: the vertex x value, the vertex y value, and the x-intercepts.
Okay.
All right, so the questions, now we can answer some questions here. So I could ask you, what is the max height of the diver? And I'm looking for the y value of the vertex here. I'm looking for number 2.
Number 2. Oh, okay. So
I'm looking for that y value of the vertex, because that's where this point is right here. It's literally at 316, but
Mhm.
it's that value right there is what it's looking for.
Okay.
Now another question I could ask, how far away from the board or the starting point does the diver hit the water? You swim, is that right? If I remember
Yes.
that, is that
Yes.
true? Okay. So you know from your experience that this is where you hit the water right there. Boom. Okay.
Mhm.
So this is asking for the x-intercept.
Okay.
Do you see that? Like it's where you go in, dive in. I know when you dive, you don't go in perfectly up and down, but you more or less hit the water and
Mhm.
go in. Okay. So what you have to be able to do is take these words and convert them to, well, which of these values is it asking for? So then like kind of related to this question right here, it's a little awkward, but it would be like, how far away from the board is the diver when it reaches max height?
Mhm.
So this is asking for the x value of the vertex. It's saying how far away from the board, like horizontally, basically. See how the horizontal distance is the same everywhere
Mhm.
when it reaches the max height? Is that okay?
Yeah, that makes sense.
Okay, fantastic. Okay, so when you're looking at these problems again later on, we're gonna move away from this to some other stuff. You really have to like reconcile that the question is just asking for one of these 3 pieces of information typically.
Okay.
Typically, I mean, it could ask for other things, but those are kind of your general guidelines.
Okay.
Okay, I'd like to move to a variation on question 1 unless you really think you're going to get exactly this. I'm talking about a corral is made from 200 feet. There's kind of a couple of variations on this problem that you might see.
Yeah, I think there's going to be one fairly similar to this one.
Okay. The variation on this, and I think this is worthwhile for us to do, is it will say something like you have 400 feet of material
Mhm.
and you want to enclose the largest area possible. Okay, so there's no picture, and this is kind of the harder variation on this problem. There's no picture. Okay, so for example, you could build something that is one foot there, 1 foot there, and that's and then 199 and 199.
Mhm.
Okay, or you could go the other way, which ends up being the same area, but I'll just draw it here. 1, 1, 199, 199. Okay. And these both have the same area. They're basically the extremes. But do you see, maybe you can visualize this, like imagine pulling this bottom or this top to make it wider. That there's probably something in the
Mhm.
middle here that's better.
Okay.
Do you agree with that?
Yeah.
Okay. And that's the idea of the table. So like for example here in your problem, it would be like, well, what would X be and what would Y be? And then you might even do like, what is the area? The area, which is X times Y. So for example, and yeah, you gotta be careful here because the numbers aren't always great. But if we do like 1 and 199, basically these two numbers have to add up to 200. The area is 199. And let's say you do like 10 and 190. You can already see that it's much bigger. It's 1900.
Mhm.
And let's say you go like 40 and 60. What's even bigger?
Okay.
Now the reason these numbers work like this is because of this first part that's very important here. You have 400 feet of material. So if we draw a much more generic shape, a rectangle, we call this X and this Y and this X and this Y, Y. The perimeter is X plus Y plus X plus Y, going all the way around, more commonly 2X plus 2Y. Did you see this in class, this sort of this idea of perimeter?
Yes.
Okay, great. So the perimeter is 400. They're telling you in this problem, they're saying you have 400 feet of material. They're telling you the perimeter is 400.
Mhm.
Okay. So if you divide everything by 2, actually, let me write that in case you looked at it later. Divide by 2, you get 200 equals X plus Y. Okay, and that's where I was coming up with these values in the table. Like these two numbers have to add up to 200. Or,
Okay.
well, I really messed up this one. 40 and, sorry, and 160 ends up being 6,400. But the point is it just gets bigger and bigger. Okay, so but the problem is there's too many combinations of this, right? Like it's 1 and 199, 2 and 1, like there's just too many.
Yeah.
So there must be another equation. What are you trying to minimize or maximize in this problem?
The largest area possible.
Exactly. So that's our second equation. This is where it gets a little confusing because it's yet another variable. Area is x times y, okay? But you can generally solve one equation or the other. You can solve this for x or y.
Okay.
So if we solve it for y, we get y equals 200 minus x if you just move the x over.
Okay.
So this right here goes in for y there. You're substituting. So area is equal to x times 200 minus x.
Okay.
All right, so it's 200x minus x squared, like that is your area.
Okay.
All right, so the do you agree that this is a quadratic here?
Hmm.
So a quadratic has the following features, right? It has a vertex and it has an x-intercept. So when this particular problem asks for what is the maximum area, it's asking for the y value of the vertex, the peak.
Okay.
So how do we find the y value of the vertex? Well, let's go back and look. So the y value of the vertex comes from first getting the x value. We got to get the x value of the vertex.
Mhm.
Okay, so let me rewrite this equation. It's a of x equals 200x minus x squared, but this is actually not written in the right form. It should probably be written like this: minus x squared plus 200x. Remember, it's in descending order: ax squared plus bx plus c. So your x value is minus b over 2a. Do you see that your a is -1 and your b is 200 in this problem? That's -1 for a and b is 200. And it's important that you write it this way so that you get the proper value for each coefficient.
Hmm.
So this is minus 200 over 2 times -1, which equals 100.
Okay.
But that's not what we want. We want the y value of the vertex. So to get the y value, you put 100 in for x. You put this value right here back into the original equation. 200 times 100 minus 100 squared.
Okay.
Do you have a calculator handy?
Yes.
Okay.
I got 10.
10,000, perfect. Now, what's really important also in these problems is units. And I didn't really emphasize that in the earlier parts, but because it's an area, because it's feet times feet, it's feet squared. And your instructor is expecting units
Okay.
when you do this. Okay, so that's the maximum area. Okay, but here's what else it could ask. It could say, what are the dimensions of the rectangular what a corral, rectangular corral. So they're literally asking for, well, what's X and what's Y? Well, we already have X. X actually is this X value. X is 100 feet. Y, though, we don't have. Now, there's a couple of ways to get Y. The best way, in my opinion, is to go back to the equation for Y. Do you see how you solve for Y right here?
Mhm.
That's the best way to do it. Y is 200 minus X. It's 200 minus 100, which is 100 feet. So sometimes your instructor even expects you to say, like, in a sentence, the dimensions of the corral
Mhm.
are 100 feet by 100 feet. Okay, so let's do your problem, because you're going to see it's really similar. Different numbers, of course, and a different shape, but it's the same process. So in your problem, you have a corral that's made with 200 feet of fence. Okay, and your instructor here, they've been kind enough to actually label these for you. You may or may not get that on the test. So what's missing, though, is that X is actually also down here.
Okay.
Now, this 200 feet, it's not just the perimeter this time, because you have to also include this middle fence thing. Do you see that?
Yes.
So it's all of these together. So just as long as you get them all, and what some students do is they just count. They go y plus y plus y, 3y plus 1x, 2x, 3x, 4x. That has to equal 200.
Mhm.
Okay, now, what are we trying to maximize? And it's the area again. The
Oh,
area, though, it's not just one of these, it's two of these. So there's a couple of ways to do that. It's 2x plus x, which is 2x times y, right? Or it's x times y, and then there's another one, so 2xy.
okay.
So here's the reality: is you always get two equations with two unknowns. Now, you might think A is an unknown, but that's the thing you're trying to maximize, so you don't count it. And you generally solve one equation for y. In this case, it's going to be this one here on the left. So that's 3y equals 200 minus 4x, because you're first going to subtract 4x from both sides.
Mhm.
Then you're going to divide by 3. As a reminder, it's not a choice. You have to divide both by 3. And if we bring down the area function, area is 2xy, you're going to take all of this and substitute it in for y. So your area equals 2x times 200 over 3 minus 4/3 x. So that's 400x divided by 3 minus 8/3 x squared.
Mhm.
And of course, x squared and x, they could go in the numerator if you want. Is that okay?
Yeah, that makes sense.
Because there's a lot here, and but from here, it's very similar to what we did previously. But the setup, starting from the picture to writing the equation to the area was slightly different.
Mhm.
But you're okay up to this point.
Yes.
Okay, so again, we can slightly rewrite this where we put it in the right order, the descending order. The operator goes with the number. Okay, and this is your ax squared plus bx plus c. So that allows you to designate your a and your b values.
Okay.
Okay, now the next part is to find the x value of the vertex. It's minus b over 2a. So it's minus 400 over 3 over 2 times minus 8 over 3. I'm not sure if that works out perfectly. I think it does. Yeah, it becomes 25.
Okay.
So x is 25. If we go all the way back to the beginning of the problem, we remember that it's in feet. So x is in feet.
Mhm.
Okay. And we can then find the y value. So the y value is from putting the x value back in to the quadratic. So you're putting it back into minus 8/3 x squared plus 400/3 times x.
Okay.
And that one doesn't work out as nice, but it's 1666. Really? Minus 8/3. Sorry, I'm just a little shocked it didn't work out a little nicer, but because y is really no. I'm sorry. I'm sorry. This is the area, not the y value. This is the area of x. Okay. To find the y value of the fence, you have to go back to the y value equation, which was this one right here.
Okay.
And that ends up being 33 1/3 or 33.33. Just slide all this down. So I got kind of ahead of myself on this one. So the y value, but that's of the fence. And that's, I think, where this gets confusing because there's the y value of the vertex, which is different.
Mhm.
So this ends up being 33.33 feet. So the area is X times Y for that one. Okay, let's look at another problem here, but let me have you do a bit more of the work, but I'm going to help guide you through it.
Okay.
Just to see, give you some confidence leading into the test or quiz coming up. So this is a cost function. Now, this is the first one where the graph actually opens up instead of down. And it's because of this right here. Why does this one open up instead of down?
Because of the plus 12.
Yeah, a is greater than 0. So if we rewrite this in the sort of the preferred form, ax squared plus bx plus c, the sign here tells you whether it opens up or down. Now, since it opens up, the only thing you actually care about in these problems is the vertex. There's no longer an intercept typically that you care about, x and a y value. But you find the vertex the same way. So the vertex here is minus b over 2a. Could you figure out that value? And if you need to round to 4 decimal places.
Okay.
I think that's enough. Barely enough. Okay. No, I'm sorry. I'm sorry. Again, this thing just round to 1 decimal place. I'm sorry.
I'm not sure, but is it 18,600?
What is your b value?
My B value is negative 3,100.
Okay, good. And then what is your a value?
The A value is 2 and then 12.
12, yes. Now, in terms of how you enter this in the calculator, which we didn't really cover, but you have to remember there's actually a second set of parentheses here.
Mhm.
And because what I heard is you divided by 2 and then multiplied by 12, which is I think why this problem was written. So here's how you might enter it in your calculator: minus 3,100 slash parentheses 2 slash 12, like this. That's the calculator line.
Mhm.
What do you have for that?
Let me enter it again. 30. 129.16.
Let's go 129.2. Okay.
Okay.
Now, how would you find the y value of the vertex?
To find the y value,
You have to
okay.
do something with this value right here.
You wait.
And here's the original equation.
Do you
So let's go
plug
back. Go ahead. Good. Sorry.
do you plug the 129.2 into the original equation
Yes.
for
X.
X? Okay.
Yes. Okay. So can you do that for me?
Yes.
Actually, it gives a negative number, which is out of scope, but it's okay.
I got negative 22,489,69.6.
I got something slightly different. Now, maybe I made a mistake here. You plugged it in either this line or the one below it.
I used the original function.
Okay, let me try it here. I get minus 50,208. Maybe check. I got that number twice.
Oh, okay. It's
Probably something small. Maybe if missing a zero or not squaring or something. That's okay. The key here is like being able to reproduce these calculations on a quiz or a test. So let's look at another function here. It's another cost function. And I want you to tell me whether this opens up or down.
it would open up.
It does open up. That's because of this right here. I think it's really important to rewrite it in that descending order, because it helps you. And when I say descending, I'm referring to the exponents here. It helps you determine the value of A, B, and C.
Okay.
So in this case, A is 0.075, B is minus 120. It always takes on the sign, and C is 70,000.
Okay.
Go ahead.
Sorry. So when you're trying to find, I'm sorry, what was the step that we were doing for the last problem where it was the 150,000 and then you plug in the 129.2? What step was that?
That's finding the Y value of the vertex.
Okay.
And we're going to do that. We're going to do, go ahead.
So when finding the y value of the vertex, when you use the original function, would you use the one from the problem, or would it be easier, or do you use the one where it's like the descending?
They both should give you the exact same answer. So
Okay.
it's whichever one you prefer. Just maybe do both calculations to confirm if you got time. But they both start out. The first thing is to find the x value of the vertex.
Okay.
So would you so kindly see if you could determine that value?
I got 4.5.
So the value of B is minus 120, right?
Mhm.
And A is 0.075. Again, if you're going to put that in your calculator, make sure you put an extra set of parentheses around the bottom.
Okay.
That's probably the reason for our difference. I get 800.
Okay, yeah. I got
Excellent.
800 when I tried that.
Great. So the second thing here, and this will probably be our last thing, is to find the Y value of the vertex. And you do that by taking the X value of the vertex, X equals 800 in this case, and replacing X in the original equation.
Okay.
So that's the C equals, and I know it's a C instead of Y, you can think of it as Y. 70,000 minus 120 times 800 plus 0.075 times, excuse me, 800 squared.
I got 22,000.
Perfect. All right. So if you have time, Julia, I would definitely recommend redoing the questions that we did tonight.
Okay.
The ones on your paper, some are slightly more difficult, some are the same quality. I wouldn't focus so much on the ones towards the end of your page, maybe page 4 and onward. Those I mean, you can look at them, but they're just they get into more complicated things.
Okay.
But thanks for allowing me to help you this evening, and I'll send you the notes here shortly, and I'll see you next time.
Okay. Thank you so
Have a
much.
great night. You're welcome. Bye now.